We have looked at permutations, we've looked at tree diagrams, other ways of representing data. What we're going to do for this activity is look at the visual representation of doing data, and you're going to do that by designing a whiteboard where you can show some of these different themes. So I'm going to, in your handout, you have instructions on tree diagrams in class activity where you need to write your name on a whiteboard, do the permutations, and also a simple tree diagram of it. So I'm going to give a quick example of the minimum of what's needed to kind of get a 7 out of 10, and then some ideas on how you can make a 10 out of 10 or perfect whiteboard. So the first step is simply having your name onto the whiteboard, and then from there, you're going to look at the permutation options. Now some of us have a much simpler name, and then that's not going to get full marks. My name is at most going to get 7 out of 10, so I could do a first and last name, I could do some other complication with it. Step 1 with any permutations is looking at the number of items you have, and in this case I have 7 letters, so I have to start with 7 factorial, because once I start to use a letter, I don't have as many options. So for my first blank, I can use any letter I want, and then after that I only have 6, after that 5, 4, 3, 2, 1. So all possibilities for my name are 7 factorial, but I have duplicate letters. And so if I was to write out Freeman and then write Freeman again and switch those 2 E's, I don't have another option. And then from there, I'll go to 7 factorial divided by 2 factorial to go and deal with the double counting of the E's, put that into my calculator, and then I'll go and get the final number. So that's the one task, and I encourage you to do something that's more complex. I could do Ben Freeman, I could do some other name like that too. You don't have to use your name. If you want to do something else that you can do the permutations of, then just make sure your name is somewhere else on the whiteboard. So that's step 1. Step 2 is to do any kind of simple tree diagram. It could be related to this, but sometimes that makes it more complex. You could also just do a tree diagram like we've done in class, or maybe you do a progression of different ways that a coin can be flipped. So having the heads and tails on a coin flip, and then I could go into another tail flip from there, and into another flip. Remember that any tree diagram needs labels, and so I would have to do something like saying flip 1, flip 2, and flip 3. And this whiteboard is getting a maximum of 7 out of 10, probably 6 out of 10 because it's a little too simple, and it could be neater. Ruler isn't needed everywhere, but it would have been beneficial here. Of course, I would have to go and solve this out too. So what are options that you could do to go and show you're learning better and make this more complex? More complex name. Or something else that's kind of creative but still appropriate that could be there. I think one of the favorite ones I had was a student that pretended he had an email account for like a dating website called Ethan Skinner at christianmingle.ca. And by the time you got all of those letters and codes in, it was a really complex thing. Even if I was to go and put in my first name, Ben Freeman, that brings enough extra complication because now I have 3 E's and 10 to start. So Ben Freeman would be 10 factorial. Now I have the 3 E's, so I have to divide out by 3 factorial, but I've also picked up an extra N. So that in itself brings enough complexity. When it comes to the tree diagram, just do something that has some layer of complexity here. Not just rolling coins, flipping coins or rolling dice. We could also do things like combinations of it. The other option is that you don't have to do the traditional tree diagram. I could do a tree diagram linked to math courses in this school where everyone has to start by taking 9 academic math or 9 applied math. And then from there, it's not going to branch out in the same way. Here you could do 10 academic or 10 applied, but the branching gets unusual. You could also go from academic to applied, but you couldn't go from applied to academic. It gets even more complex when you get into grade 11, where you have 11U, 11UC, and 11C. And a lot of these start to link. And then when you get into the grade 12, you have a grade 12 calculus. Oh, I should do this in another way. We start with grade 12 functions, which can only lead to grade 12 calculus. We have grade 12 data management, which you can get to from UC or from U. And we have grade 12 college, which primarily leads from 11C, also 11 UC, and I'm using a dotted line here to show it's possible, just doesn't happen very much. So any kind of tree diagram that you can represent that has some level of complexity, even if it doesn't build in the logical way we normally assume, would be a good addition. So this, in with a more complex tree diagram, well represented, 10 out of 10.